Hi you guys, we are going to get started on our first lesson, which is 911. We are going to be learning a lot about different angle relationships, especially when you have two parallel lines. So I've started out here. Actually, let me back up and say, if you want to take notes while I am going through the lesson, just like we do in class, I encourage you to do so. Or if that's difficult for you, you can just watch the video and then refer back to it as needed as you work through the review preview problems that will be assigned based on this lesson. So to get started, let's just go over some vocabulary and some symbols that you will be seeing in this lesson. You'll see here that we have two parallel lines, and oftentimes the parallel lines will have little markings on them that indicate that they are parallel lines. So look for that. And then I'm going to add a third line to this, which is called a transversal. This transversal cuts through the two parallel lines, and in doing so, it creates a whole bunch of different angles. So we're going to talk about those angles and the relationships. But before we get into the angles, let's talk about the interior and exterior parts of this diagram right here. The exterior region in this diagram is this area that I'm highlighting above the top parallel line and below the bottom of the two parallel lines. These are the exterior, pencil's broken of course, the exterior regions. That means the part in between the two lines, in here, this section is the interior region. Okay, so we have some exterior angles and some interior angles. I'm going to start numbering these angles. Angle 1 is an interior angle because it is between the two parallel lines. Angles 2 and 3 are both exterior angles above the top parallel line. And angle 4 is another interior angle. Down below we have 4 more angles. Angle 5 is an exterior angle. 6 and 7 are interior angles. And finally, angle 8 is an exterior angle. The first angle relationship that we're going to look at is alternate interior angles. Alternate interior angles are on opposite sides of the transversal, sorry about my left hand. You guys know it's always been an issue for us when we take notes in class. Okay. They are on opposite sides of the transversal, so opposite sides of this line right here, and alternate interior angles have equal measure. So if one of them is 80 degrees, then the other one is 80 degrees. So let's take a look at which ones are alternate interior angles in this diagram here. So angle 1 is an alternate interior angle with angle 7. So we use this symbolism. Angle 1 is equal to or congruent to angle 7. And we can also say that angle, oops, that's too close of a color. Let me grab another one. Angle 4 and angle 6 are alternate interior angles. They're both on the inside or interior part of our diagram and on opposite sides of the transversal. So angle 4 would have equal measure to angle 6. Okay, we are going to move on to our next angle relationship, and that is vertical angles. So using our same diagram with two parallel lines and a transversal that create 8 angles, we are going to look now at which angles are vertical angles. By definition, vertical angles are across from one another I like to think of them as across from one another diagonally. And vertical angles have equal measure. So let's look up at this diagram and see if we can identify all of the pairs of vertical angles up here. I'll start you off with the first one. Angles 1 and angle 3 are vertical angles. They are diagonally across from one another. So that means that they have equal measure. Okay. And likewise, angle 2 is a vertical angle to angle 4. That means angle 2 has equal measure to angle 4. Take a moment and see if you can identify the other two pairs of vertical angles in this diagram. Let's see if you got them all. So, in this diagram, we saw that 1 and 3 were vertical angles, 2 and 4 are vertical angles, and in the lower section, angle 6 is a vertical angle to angle 8, and angles 5 and 7 are vertical angles, thus they are equal to one another. Our next angle relationship are corresponding angles. Corresponding angles have the same relative position, meaning they're kind of in the same place as one another, and again, they have equal measure. So let's look at the diagram up above. Let's start out by looking at angle 1's position in the diagram. Angle 1 is beneath its parallel line, and it is to the left of the transversal. Which other angle is similar to that? It would be angle 5. Angle 5 is beneath its parallel line, and it is to the left of the transversal. So angle 1 and angle 5 are corresponding angles, and they have equal value. There are many other pairs of corresponding angles in this diagram as well. Angle 2 is above its parallel line and to the left of the transversal, and that corresponds to angle 6, which is also above its parallel line and to the left of the transversal. So we also have angle 2 that is equal to angle 6 because they are corresponding angles. We have 2 more pairs left. Angle 3 is above the parallel line and to the right of the transversal, and so is angle 7 above the parallel line and to the right of the transversal. So angle 3 corresponds to angle 7, and they have equal measure. The last pair that we have are angle 4 and angle 8. They are both beneath their parallel line and to the right of the transversal. So angle 4 corresponds to angle 8, and they have equal measure. Okay, moving on to our next angle relationship, and I'm going to use my pointer just for a little bit of fun. We are going to look at same side interior angles. So you can see in this diagram now I have highlighted the interior region. Once again, that is the area in between the two parallel lines. So in that interior region, we have 4 different angles. We are looking for angles that are on the same side of the transversal, like 1 and 6 are on the same side, they're to the left of the transversal, or 4 and 7 are both to the right of the transversal. They are in the interior region. They're in this highlighted section between the two parallel lines. And the relationship of those same side interior angles is that they have a sum of 180 degrees. That means if we took the measure of angle 1 and we added it to the measure of angle 6, they would equal 180 degrees. Angle 1 plus angle 6 equals 180 degrees. Similarly, the measure of angle 4 plus the measure of angle 7 would equal 180 degrees. Angle 4 plus angle 7 equals 180 degrees. Those are same side interior angles. For our next relationship, we are going to look at supplementary angles. Supplementary angles are 2 or more angles whose sum is 180 degrees. That means if we add the measure of each angle, if it equals 180 degrees, then those angles are supplementary. If you look at this first diagram here, we have 3 different angles. Angle A is indicated by this red mark here. Angle B is in the middle. And then we have angle C, the one with the blue writing. So all 3 of these angles together make up this entire angle that goes all the way around, or creates this straight angle, which is 180 degrees. So in this diagram, although we don't know their exact measures, we know that the 3 of them put together, angle A plus angle B plus angle C, have a total or sum of 180 degrees. In this next diagram, we have 2 angles. We have angle X and angle Y, excuse me, and together those 2 angles create that straight angle. So in this diagram, angle X plus, angle Y have a sum of 180 degrees because they create this straight angle together. If we return to the original diagram that we were working with on our first few angle relationships, and we look for supplementary angles, you will see that there are many different pairs of supplementary angles. For example, I can look at angles 2 and 3 and see that together they make this straight angle or straight line. So angle 2 and angle 3 are a pair of supplementary angles. Beneath that, you can see angles 1 and 4 would also be supplementary angles. Together they create that same straight line that 2 and 3 create. If we look at it from a vertical perspective, you have supplementary angles as well. So let's look at it from a vertical perspective down below. Here we have angle 6 and angle 5 together that create this straight line right here. So angles 5 and angle 6 are supplementary angles. And on the other side of that line, angles 7 and 8 are also supplementary over here. Angle 7 and angle 8 are also supplementary. There are more pairs of supplementary angles than just those 4 pairs. Pause the video and see if you can find the other pairs of supplementary angles. Here are some more pairs of supplementary angles. Angles 1 and 2 are supplementary. Angles 3 and 4 are supplementary. Angles 6 and 7 are supplementary. Angles 5 and 8 are supplementary. And there are even more than those. Our next angle relationship are complementary angles. Complementary angles are 2 or more angles whose sum is 90 degrees. So in this diagram up here, we have 2 lines that intersect and create a 90-degree angle. We know that because of this little square marking in the corner. That tells us that that angle is 90 degrees. If we draw a ray that separates this 90-degree angle into 2 different angles, let's call it angle 1 and angle 2. Angle 1 measure plus the measure of angle 2 will be equal to 90 degrees. Let me just make up some numbers here. Let's just pretend that this angle 1 is 60 degrees and this angle is 30 degrees. They would add together to have a sum of 90 degrees. Now remember, I just made these numbers up. They are not actually 60 or 30 degree angles, but they do add together to equal 90 degrees, which means they are complementary angles. Our next angle relationship are adjacent angles, and as you can see, they are angles that share a common side. So for example, if I have this angle that I drew, and I divide it into 2 angles. Angle A and angle B. Angle A has this teal kind of ray at the top, and then the bottom of angle A is this red ray right here. Angle B also has this red ray and then the teal angle down at the bottom. So they share this common side. Angles A and B are adjacent angles. You could think of them, or I like to think of them, as next door neighbors. They are right next to each other. In fact, they share a side because they're so close. Up above in this diagram, we have several pairs of adjacent angles. Let me just point out a couple of them. Angle 2 and angle 3 are adjacent angles because they share this common side right here. I'll draw out angle 2. Okay, it's right there. Angle 3 also shares that line going almost vertically up, and then the bottom here. So angle 2 and angle 3 are adjacent angles. There are many more pairs. Let's look for one more. Angle 7. Angle 7 is adjacent to angle 8 because they share this side right here. Angle 7 and angle 8 are adjacent angles. You could also have said that angle 7 is adjacent to angle 6 because they share this side right here. Angle 6 and angle 7 are also adjacent angles. There are many more pairs of adjacent angles in this diagram. If you would like, you can pause the video and see if you can identify more pairs of adjacent angles. Here are some more adjacent angles. Angle 6 is adjacent to angle 7. Let me switch to my pointer. Angle 6 is adjacent to 5. Angle 5 shares a side with 8, so they are adjacent. 1 and 4 share this side, so they are adjacent. 1 and 2 share this side, so they are adjacent. And you can find even more than that. Again, adjacent angles are angles that share a common side. Okay, our last angle relationship in this lesson are alternate exterior angles. Alternate exterior angles are angles that are in the exterior region, and I've highlighted these. So angles 2, 3, 5, and 8 are in the exterior region. They are on the opposite sides of the transversal. So, for example, angle 2 and angle 8 are on the opposite sides of the transversal, or 3 and 5 are on opposite sides of the transversal. And alternate exterior angles have equal measure. So that means in this diagram, angle 2 and angle 8 are alternate exterior angles, and they have equal measure. Similarly, angle 3 and angle 5 are alternate exterior angles, and they also have equal measure to one another. Okay, now we are going to use all that we learned about those angle relationships to complete a few core problems from our book. The first one is core problem 9-4, and we are looking at part C. Part C shows us this diagram. We have two parallel lines, and we have 8 angles that are marked, although they're numbered differently than the ones we've been using in our notes. That's okay. They're asking us, in this particular diagram, if the measure of angle 2 is 67 degrees, then what would be the measure of angle 5? Okay. I see that angle 2 and angle 5 are adjacent angles because they share this side right here. And I also see, let me switch to a colored pen. They share this side right here. And I also see, if I mark out angle 5 and angle 2, that together, these two angles create a straight angle or a straight line, which means they are supplementary. And we learned earlier that supplementary angles have a sum of 180 degrees. So, in other words, I have my 67 degree angle plus angle 5, and those will equal 180 degrees. So to get this number out of here, I'm just going to replace the angle 5 symbol with x. And it gives me this equation, 67 plus x equals 180 degrees. So to solve this equation, we would subtract 67 from each side, and we would find that x is equal to, let's work through this, x equals 113, or we could rewrite this and say the measure of angle 5 is equal to 113 degrees. Okay, for our next example, we're still on core problem 9-4, part D this time. It's the same diagram that we used in the last problem, but it gives us some different information. This time, it says, if the measure of angle 4 is equal to 4x plus 23 degrees, just going to write that right here, 4x plus 23 degrees, and the measure of angle 6 is equal to 3x plus 17 degrees, find the measure of angle 4. They want us to come up with an exact number for this angle measurement right here. So looking at both angles 4 and 6, I need to ask myself, what is the angle relationship here? How is angle 4 related to angle 6? And right away I notice that both of the angles are in this interior region between the two parallel lines. So they're interior angles. And I also notice that both of them are on the right side of the transversal. That means angle 4 and 6 are same side interior angles. And we learned earlier in our notes that same side interior angles have a sum of 180 degrees. Or, in other words, if I added this one plus this one, it will have a sum of 180. So that guides me in setting up my equation, which will be 4x plus 23 degrees plus 3x plus, 3x plus 17 degrees will equal 180 degrees. So now I'm going to solve this equation using the steps that we've used all throughout this year. Combine like terms. 4x plus 3x is 7x. 23 plus 17, and that equals 180. Now I'll subtract 40 from each side of our equation. We get 7x equals 140. Divide each side by 7. And we find that x is equal to 20. Now we're not quite finished yet because they did ask us to find the measure of angle 4. Angle 4 is 4 times x plus 23. So I'm going to do a little side problem over here to show the measure of angle 4 is equal to 4x plus 23. I will substitute my value for x in here now. I know that x equals 20. So 4 times 20 plus 23. 4 times 20 is 80. Plus 23 gives us 103. So the measure of angle 4 is equal to 103 degrees. Okay, for our last example, we are going to work through all of the parts of core problem 9-6. Starting with part A, we are given this diagram right here. We are told that one of the angles has a measure of 123 degrees, and we need to find the measures of angles C, B, and A. And I'm going to be finding them in just that order. So looking down here, we see that angle C and angle 123 together create this straight angle. So I know that their sum has to equal 180 degrees. So I've got my calculator over here on, I'll just put it right here in the screen. So if I did 180 degrees minus 123, I find that angle C would have a measure of 57 degrees. Again, what I did there was take the sum 180, subtract the angle measure that I knew, 123, to find that angle C would be 57 degrees. Now, next I'm going to move to angle B. And I see that angle B and C are both in the interior region on the same side of the transversal. They're both to the left. So they are same side interior angles, which means they need to add up to 180 degrees. Now we just used those numbers here. I know that 57 plus 123 would equal 180 if I work backwards through the equation that I already used. So I know that angle B would have a measure of 123 degrees. And last, we can find angle A. Angle A and angle B are vertical angles. They're diagonally across from one another. And vertical angles are equal, which means angle A also has a measure of 123 degrees. Okay, let's shift our attention down here to example B. We have this diagram here. They give us the measure of one angle. It's an 82-degree angle, and we need to find the measure of the other three angles. So let's start by finding the measure of angle F. I know that this 82-degree angle and angle F together make this straight angle, which is 180 degrees. So I'm going to do 180 minus 82, and that will tell me the measure of angle F, which is 98. So angle F is 98 degrees. Now I'm going to work on angle E, and I notice that angle E and angle F are both in this interior region, and E and F are on the opposite sides of the transversal, which means they are alternate interior angles. And we learned earlier that alternate interior angles are equal, so angle E and angle F have the same measure. They would both be 98 degrees. Finally, when we look at angle D, we see that angle D is a vertical angle to angle E, and we know that vertical angles are equal, so angle D would also equal 98 degrees because vertical angles are equal. We've arrived at core problem 9-6C, which is our last problem for this lesson. In this diagram, we see that we have a 75-degree angle, and we need to find the measure of these two other angles that are labeled here. So, right away, I notice that the 75-degree angle and angle G are in the interior region. 75-degree angle is on the right-hand side of the transversal. Angle G is on the left. That makes these two angles alternate interior angles, which have equal measure. So angle G is also going to be a 75-degree angle. And last, angle H is a vertical angle to angle G, so angle H is also a 75-degree angle. That's the end of our video lesson for lesson 9-1-1. Tomorrow, your assignment is to complete the review preview problems in the lesson. The review preview problems start in your textbook on page 397, or for those of you using the ebook, you can just go to review preview in the lesson. You are going to be completing problem 9-8 and 9-9, and If you have already completed the lessons for the last 2 weeks, that's it. Those are the only two review preview problems that are your assignment. The review ones you've already done. If not, if you had not kept up with your assignments in the last few weeks, you also would need to do 9-10 through 9-13. Okay? But for most of you, you only have to do these two new review preview problems.